Let's take a look at the 2012 free response questions 4 through 6, and the questions 4 through 6 are no calculator. So question number 4, let me get my pen here. The function f is defined by f of x equal to square root of 25 minus x squared from negative 5 to 5, inclusive. Find f prime of x. So that's very direct. We're going to find the derivative using the chain rule. So the first thing that we want to do, if you come down here and look at the work, is we're going to, let's do this just so I can keep things a little bit more clear without working on the next part. All right, so the first thing that you want to do with the original function, let's come back up here, is to rewrite that as 1/2. Nope, that's a lie. We want to write that with a fraction power, 25 minus x squared, I'll fix that in a second, to the 1/2 power. So we're going to do the algebraic rewrite to get it in a format that's going to be easier to work with. And so that's what our function is going to look like. And so when we do the chain rule, we're going to work with the outside function. So we're going to use the power rule and decrease the power by 1 and then multiply by the derivative of the inside, classic chain rule. So down here, so when we do that, let's see if I can keep both things on the screen. There's the 1/2 coefficient multiplied in front. There's the decrease the power by 1. Leave the inside alone, and then take the derivative of the inside, and the derivative of negative x squared is negative 2x. That can be rewritten, it does not have to be rewritten to get that answer point. So again, let me repeat that. You do not have to rewrite that in order to get the answer point. And I think I said that right down here. All right, letter B. Write an equation for a tangent line. So we know that when we write the equation of a tangent line, so with a line tangent, remember the first thing we're going to do, we always do, is write down our form for the equation of a line. Y minus y1 is equal to m times x minus x1. And then we're going to need to know the y number 1. We're going to need to know the x1, which is given to be x equal to negative 3. And then we're going to need the derivative at negative 3. And remember, in part A, we just generated the derivative. So to find the y value, we're going to substitute negative 3 here, and that'll give us the y value. So if you come down and look at the solution, let me slide that down for you. Well, didn't mean to make it disappear. Let's do this. And sorry about that. So in letter B, the first thing that they're doing here is they're generating the y value at negative 3. And so, or the slope, I'm sorry, they're substituting negative 3 into the slope that we found back here. So you get 1 point for getting the y value of either 3/4, or I remind you again and again and again and again and again and again and again that you could leave your answer. That way you can actually put that in as slope, and then you're going to get 1 point for your answer. So hopefully you would have generated the y value of 4, and then you would substitute. And remember what I told you all year about getting y by itself. That's really important. And the 4 could be in the back. It doesn't have to be 4 plus. It could be 3/4 times x plus 3 plus 4 in the back. So 1 point for having the correct equation. All right, and then going back to letter C, continuity. Ladies and gentlemen, I want you to spend some time looking at the 3 conditions of continuity. This comes up quite often on the AP test, and students are expected to know the definition of continuity. So for the definition of continuity, there are 3 things that have to be true. 1, f of the x value in question, in this case, I'll just write it in terms of this problem, f of negative 3 must be defined. In other words, there must be a y value. We know that's the case because we generated it. Oh no, we're looking at g now, I'm sorry. We're looking at the function g. Number 2, and we have a piecewise function, the limit as x approaches, can I draw an arrow? I'm just going to type, approaches -3 must exist. Now that means we're going to have to examine the limit from the left and the right, and we'll talk about that in a second. And then the third thing is the f of -3 must equal the limit as x approaches 3. And you're going to have to prove all three of those things in order for this to be true, as x approaches -3. Okay, so we have a piecewise function. If you'll come back up here and look at the piecewise function. So first of all, we want to find the y value at -3. So if I look at the piecewise function, I'm going to substitute -3 into the first piece because that's where the equal to is. So to find g of -3, I really need to use f of -3, which we did already generate in the last part, in part B. Now, in order to find the limit as x approaches -3 from the left and the right, so this would be coming from the left side because it is x is less than -3, and this would be coming in from the right side. So I want to substitute -3 in place of x, and -3 plus 7 is 4. Now remember from our work in part B that f of -3 is also 4. So the left and right limits do agree with each other. And they equal the y value. So let's see how we're going to write that up. Now, first we're going to look mathematically how a math teacher would write it up, and then we're going to look at how I'm going to show you actual student work. Okay, so the first thing that they're doing is showing that the limit as x approaches -3 from the left equals the limit as x approaches 3 from the right, and that was equal to 4 as we talked about just a minute ago. So they said the student must talk about considering the limit from both sides in order to get that first point. Secondly, we have to have an answer with explanation. So this was the limit as x approaches from the left. This is the limit as x approaches from the right. Therefore, the overall limit, so they're doing the limit work right here, proving that the left and right limits equal each other. Therefore, the overall limit is 4. And then they're going to go forward to say that the y value of g at -3 is 4. And they agree with each other, therefore we must have continuity. Let's look at student work to see how a student would actually write this up. So student number 1, this student earns all points, and I'm going to change to a green. The student earns all the points for this part, and notice again, they're doing the limit from the left, and they're showing that, the limit from the right, and they're showing that, and the limit overall, and they're showing. Gentlemen, if you did not get it right this time, make sure the next time you see a continuity question, maybe on a quiz, you get it right the next time. And then they tell me that the actual y value is also equal to 4. In number 2, the student earned no points. Now they did find the y value right here, and they're doing something here with the other piece, but they didn't really tell me what they're doing. And they're just saying, yes, g of x is continuous. And let's see what they say down here. In order for a function to be continuous, the limit as x approaches 8 from the right, h from the right, must equal the limit as x approaches 8 from the left, and the actual value of the something must be equivalent to the value that f. So the student sort of has an understanding, but it's not specific to this problem. They're not talking about -3. There's just not enough proof there. They're just telling me some facts that they know, but they haven't really proven it with f and g and -3. So even though the student sort of has some idea of what they're trying to convey, it's not conveyed precisely and specifically enough, but this student work is very good. And then finally, let's go to part D. I'm going to clear my window. I'm going to reset that. So in part D, We are trying to find the value, evaluate a definite integral. This is going to require some U-substitution. So remember, we're going to let U equal to the inside function. I strongly recommend changing the bounds. So let's get rid of that. And let's get this in the window. So we're going to begin by letting U equal to the inside function. Take the derivative. We don't need that -2, so we're going to divide it to the other side. We're going to make the substitution, and notice again, what you have to be really careful of is you got to change those U bounds into X bounds by substituting here, and that's where we get from 25 to 0. Now, you can reverse those bounds, or you can leave them as they are. If you reverse the bounds from 0 to 25, then you're just going to make that a plus, and you will get the same answer. 2 points for the antiderivative and 1 point for the answer. All right, let's move on to question number 5. The rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At a time t equal to 0, when the bird is first weighed, its weight is 20 grams. So you know what I'm going to do. 0, whoops, no I'm not. 0, 20. Okay, there's my initial condition. Continuing on in my reading. If B of t, the weight of the bird in grams. Okay, so B of t equal weight in grams. At t days after it is first weighed, then dB dt, so B of t is the weight, dB dt, let's write that over here, dB dt is the rate of weight. Okay, so that's how the bird's weight changes over time. So we have a differential equation, and that differential equation is in terms of B. Continuing to read, let B of t be the solution to the differential equation. In other words, if we go back and undo or solve this differential equation, that will take us back to the bird's weight. And we have the initial condition 0 to 20. This is not a directive, this is just information. Letter A, is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Explain your reasoning. So in the diagram, we can see that we have time here, and this graph is the bird's actual weight. And we want to know if the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams. So the word faster is making me think that we're talking about a rate. Remember, reading is the most important thing with these problems. So I am simply going to substitute 60 and 30 into my weight rate, remember, which is dB dt. I'm going to compare the two numbers. The arithmetic is easy. This is with no calculator, and I'm going to compare. So there's 1 point for using the rate and 1 point for stating the answer that the bird is gaining weight faster when it weighs 40 grams. So hopefully you didn't find that to be too challenging. In letter B, we are now finding the second derivative. So we're going to do some implicit differentiation to explain why the graph of B cannot resemble this graph right here. Now remember, second derivative from the All About Me sheet is used to determine what? And hopefully you said, say it again, concavity. So second derivative is primarily it can be used for other things, but is used for concavity. Now the reason that I thought about that is because you can look over here at this curve and see it is a curve that is concaving. For example, in this region, the curve is concave up, and in this region, the curve is concave below. So my first instinct, without doing the work, is that I'm going to use the second derivative probably to refute the concavity in one of these regions. So to do that, I have to start by finding the second derivative. Let's see if I have my work shown I have student work shown for that. So we'll go through the math work and then we'll go through the student work. So when we find the derivative, my suggestion, if you had trouble with this, anytime you've got these parentheses here and you've got to find the derivative, go ahead and unlock those parentheses by multiplying through by the 1/5, because then we can rewrite this to be dB dt is equal to 1/5 of 100 is 20 minus 1, I'm going to put this in parentheses, 1/5 of b. And that's way easier to take the derivative of, because when you take the derivative of 20, you're going to get 0. When you take the derivative of negative 1/5 b, you're going to get negative 1/5. So the derivative would be, get my typing here, my derivative is going to be negative 1/5, and the derivative of b is 0, but chain rule, dB dt. But remember, for a second derivative, implicitly, go back and watch your lesson videos if you need to. When we do that second derivative, then we've got to take dB dt and substitute it. Come on, you can do it, Jernigan. And then substitute it in place of dB dt. So then that's going to become, let's see if I can type this for you, in parentheses, we will have negative 1/5, and I'm substituting what I had up there for dB, so there's another 1/5 times, this is kind of messy because I'm trying to separate my fraction with parentheses, and another closed parenthesis, okay? So then I can leave my work like that and substitute or consider the b values, or I can clean up. So let's look down here at the second derivative. They cleaned it all the way up and they got negative 1/25 times 100 minus b. So they just multiplied the negative 1/5 times the positive 1/5. So the graph is valid from 20 to 100. So if we're only substituting numbers from 20 to 100, as you can see right here, these are the bird's weights. If we're substituting numbers 20 to 100, then 100 minus b is always going to either be positive or going to be 0. So if I multiply a positive number times a negative 1/25, I get a negative, indicating that the graph should actually be concave down over this entire region, but this graph has a concave up region. Okay? And then I was going to show you student work on that. So part B, this student in part B gets all of the points. They did what I suggested. They multiplied the 1/5 in. Then they took the derivative here, substituted. They multiplied everything by the 1/25 and came up with the same conclusion. They solved all the way for b and got b greater than 100, which is positive. So therefore, the graph has to be concave. Oh, wait a minute. What did they do? Concave cannot be concave up when its weight is below. Oh, yeah. B is greater than 100. So the graph cannot be concave down, which is what I said before. I mean, concave up has to be concave down, which is what I said before. Sorry, I didn't mean to be confusing there. The second part, in part B, the first point was for this student, student number 2. The first point was not earned because the student does not present the second derivative in terms of b. So when they did right here, the student just left dB dt. They did not replace it with the value of dB dt. So they're not getting the first point. but they still got the second point because they still convinced us about the concavity of the curve. And in student number 3 on part B, the student got no points. It's just kind of a mess. Oh, I know. When they took the derivative, they did not get a dB/dt at all, so they did not use the chain rule. All right, let me clean my screen up here, and let's get to part C. You knew it was coming. Separation of variables, separate, integrate, solve. So to separate the variables, we're going to divide both sides by 100 minus b and multiply both sides by dt. And I think I have my work for that. No, I don't. I thought I did. Oh, yeah, I do. Hey, yay for me. So here's what it looks like slowly. So I separated the variables. I divided both sides by 100 minus b, and I multiplied both sides by dt. Now, this is sort of a little baby U-substitution. When you let u equal to 100 minus b and you take the derivative, you get a -1, so you have to compensate for that. So that's why we get negative ln, because we have u prime over u, or 1 over u. And on the right-hand side, anti-differentiate, that's the easy side, so we have to anti-differentiate on both sides and add the plus c. Then, in the next step, I divided both sides by the negative. And notice when you divide a plus c by a negative, it still is a plus c. And then I did the undo the ln by exponentiating or raising both sides to the power of e. And then I brought down the c using laws of exponents. That's our PERT format. Subtracted 100, divided by -1. And then substituted the initial condition, found the value of c, and resubstituted that. So you can pause the video if there's any part of that you need to study. Honestly, guys, you can do this. It's all about I can't ever spell this word, persevere. I think it's spelled right. Persevere, you can do it. So the point values for that one are 1 point for a good and correct separation. 1 point for getting both antiderivatives. If you missed one side, you didn't get the antiderivatives. 1 point for the plus c, 1 point for using the initial condition, and 1 point solving for b. Now the question really comes in, and I don't really have a great answer for you, is how badly can you mess up these antiderivatives to get particularly these 2 points? And generally the rule of thumb is if the student does some sort of anti-differentiation that makes the problem really easier to do, then they're pretty much not going to get these last 2 points. So let me clean that up a little bit and clean up. All right. So the student gets a maximum of 2 points if they have no plus c. So that's, a big problem. And 0 out of 5 if there's no separation of variables. But other than that, it's hard for me to say how many points you would get if you messed up one of your antiderivatives, because it kind of depends on how badly you messed it up as to whether we get to continue to read with you or how many points you're going to gain on that. And then finally, let's go to problem number 6. In problem number 6, we have our particle motion problem. In this problem, we have a particle moving along the x-axis, which happens a lot. We have velocity given, and the velocity happens to be a trigonometric function. So their College Board is sending you a letter. Dear student, we expect you to know trigonometry on the non-calculator part. The position of the particle at x equal to, or is at x equal to -2 at time 0. So we have the initial condition of 0, -2. Letter A. From 0 to 12, when, we want a time, is the particle moving to the left? All about me sheet. You, all of us know that particle moves left when v of t is less than 0 or negative. So we're going to have to first figure out where is velocity equal to 0 by setting cosine pi over 6t equal to 0. All right, so to do that, I'm going to do it right in here. I'm going to change my color to blue. So cosine of pi over 6t close equals 0. So I have to think to myself, when is cosine equal to 0? And they lock me from 0 to 12. So cosine, I'm trying to see if I did this work anywhere. It's likely that I might have done that, but maybe not. No. All right, so let's talk about that. So cosine itself is equal to 0 when the value of x is equal to 0. So that's going to be at, cosine is 0 at pi over 2 and 3 pi over 2. So that means I'm going to set, oh, this is kind of hard. Let me get my equation editor out here. Where are you? Insert equation. All right. Hopefully this will be better for you to follow once it actually starts. There we go. All right, let's see what I can do here. So, since cosine is 0 at pi over 2 and 3 pi over 2, I'm going to set my angle, which is pi over 6t. So I'm going to start with a fraction. You know what? I'm going to pause the video and type this up to save time so you don't have to sit here and watch me type. So And it's a miracle. It has happened. So I have the angle measurement pi over 6 is equal to pi over 2. Or the angle measurement pi over 6 is 3 pi over 2, because remember that's where cosine is 0. To solve, I'm going to multiply both sides by 6 over pi. I'm going to do the same thing over here, multiply by 6 over pi. The pi's divide out here and here. 6 divided by 2 is 3. Pi's divide out here and here. 6 times 3 is 18, divided by 2 is 9. So those are the times where the particle is equal to, where the velocity, is equal to 0. Now I'm going to take 3 and 9 and put them on a number line. I'm going to put them on a number line, and then I'm going to choose a number in each region. And remember, this is only valid from 0 to 12. So when you're making a number line, insert shapes. When you're making a number line, you really only need to start, we're going to start at 0, we're going to put 3, we're going to put 9, we're going to put 12, and so my endpoint is at 0, then I have 3, then I have 9, and then I have 12. And so I'm going to test each region between, I'm going to test the region between 0 and 3, 3 and 9, 9 and 12, substituting those numbers into the velocity to determine when the velocity is negative, and that occurs from 3 to 9 if you do your arithmetic carefully. All right, that's letter A. Letter B, let me erase this and get rid of that. In letter B, write but do not evaluate an integral. So straight up, we know we need an integral that gives the total distance traveled. That means for total distance travel, the area must be positive. The easiest way in the world to do that is to put absolute value around the velocity function. So that's the method. I'm not going to break it up into parts. That's just too much drama. So down here in part B, you can see that put not around the integral, around the function only. And so you get 1 point for that answer. Back in letter A, you get 1 point for if you set v of t equal to 0, ladies and gentlemen, even if you don't get it right. If you set v of t equal to 0, you get a point. You get a point. Don't give up. Show everything that you know. In letter C, we are now going to find the acceleration, which is the derivative of velocity. So I'm finding the derivative. I have an inside-outside function, so I'm going to need the chain rule. So first, when we do the chain rule, we're going to take the derivative of cosine, which is negative sine. If you have not done your trig derivatives and said them about 100,000 times, it's getting time to do that, ladies and gentlemen. So I'm going to take the derivative of the outside, and then I'm going to multiply by the derivative of the inside, which is the angle. Derivative of cosine, negative sine, leave the angle alone, times the derivative of the angle itself. So the derivative of cosine is negative sine, leave the inside alone, and then the derivative of pi over 6t, pi over 6 is the coefficient, is just pi over 6. And then after that, after we find the acceleration, we want to know about speed. So remember that speed requires two quantities. For speed, we need to know the sign of velocity, and acceleration. If we have the same sign, okay, you can't see that, that's great. If we, let me move this over. Oh, come on, please cooperate with me. Something work. Yep. Same sign. Speed up. opposite sign, slow down. Okay, so we're going to substitute 4 into the velocity function. So we found that was the original function. So 4 pi over 6 is 2 pi over 3. Cosine of 2 pi over 3 is in the second quadrant, and cosines are negative. And then we're going to substitute 2 pi, what was it? I already lost my train of thought. Then we're going to substitute 4 into the acceleration function, which is here. And in the second quadrant, sine values are positive, and a positive times a negative is a negative. You don't really have to generate the number, but you do have to prove that where you have a positive and a negative or whatever. And so since the acceleration and the velocity have the same sign, the particle is speeding up. So what do you get points for there? 1 point for correctly using the chain rule and getting the acceleration function. 2 points for your conclusion with your correct answer. And then finally, in part D, let's change colors. Find the position, which is different from distance traveled. So now we don't have to worry about signs at time t equal to 4. But hopefully you did not remember that there was an initial condition. So position needs position. Back here when we did total distance, I hope you did not put a -2 in front of that. Distance does not need an initial position. Distance is simply measured from the time interval 0 to 6. But the position needs position. So down here, I'm going to start by setting up the integral. -2 is the edit undo. So -2 is the initial condition, starting at 0, stopping at 4, accumulate to all the area, not worrying about the sign. All right, so there's 1 point for getting the correct antiderivative and 1 point for the initial condition. Now look, don't despair if you had trouble with this, because there's only 1 more point left for the answer. And you got to do all of this. So 2/3 of the points are done right here. All the rest of this work is only 1 point. So we have to do a U-substitution, and you can pause the video and look at it as long as you like, but we're going to let u equal to the inside function, take the derivative here, multiply both sides by 6 over pi. I changed the bounds and kept everything in terms of u. I did my substitution and I left my answer unsimplified. So this answer over here is perfectly fine. I don't have to, in this case, evaluate sine of 2 pi over 3. So make sure that you know and understand that. So hopefully this helps you to figure out your strengths and weaknesses. Go back and strengthen the weaknesses and maintain the strengths. All right, that's all for this video.